Hi, multiplication fact strategy teachers. Today we're going to be talking about the splitting strategy. So the splitting strategy is a multiplication fact strategy where you decompose or split apart a multiplication fact, an unknown multiplication fact or a new multiplication fact, into two or possibly more smaller benchmark facts. So you're actually decomposing or splitting one fact into two smaller benchmark facts that a student knows. Let's take a look at that a little bit more closely. So here is the new fact 8 times 3. And if a student didn't know the fact 8 times 3, they could use the splitting strategy to solve it. In the splitting strategy, you split one of the factors into two smaller factors that will help you. So 8 is a great number to split. I can always split an 8 into a 4 and a 4. And you can see here I represented that with a number bond, showing that I'm splitting or breaking apart or decomposing this 8, this factor of 8, into two 4s. And something that it's really valuable to point out to students is that when you're splitting a factor, the numbers you're splitting it into are the parts of that number. So 4 and 4 are parts of 8. So I'm splitting apart or breaking apart or decomposing that 8 into two of its parts, 4 and 4. Those together equal 8. So you can see here, I've represented that with a number bond. You can also see on the area model here, this side length of 8 on this 8 by 3 rectangle has actually been split or decomposed or broken apart into two smaller lengths, 4 in this rectangle and 4 in this rectangle. So there's actually now two rectangles. And 3 is the factor we did not split. So 3, or I should say the factor you did not split, becomes the common factor. 8 times 3 has a 3, and both of your benchmark facts will also have a 3. It would be the common factor between your new fact and your benchmark facts. You are decomposing one fact into two smaller benchmark facts that you will add back together. So you can see I have kind of provided a frame for an equation here, an expression here, where we're going to actually have two separate multiplication facts, the first one and then the second one, and we're going to actually add those back together to ultimately find our total answer. So when you're using the splitting strategy, you are distributing the two decomposed factors. So the 8 that we've decomposed into a 4 and a 4, you're going to distribute those into the two benchmark facts. So your first 4 goes into your first benchmark fact, and then the other 4 goes into the other benchmark fact. The 3, of course, that we did not split, we've already talked about how that's our common factor. It's in both of our benchmark facts. So now we have two benchmark facts instead of one new fact, or we have the one new fact of 8 times 3 has now been split into the two benchmark facts of 4 times 3 and 4 times 3. And to find the answer to 8 times 3, we'll have to take 4 times 3 and add another 4 times 3 rectangle. And when we look at the area model, we can clearly see that our 8 by 3 rectangle has in fact been broken apart or split or decomposed into two 4 by 3 rectangles. So now we just think to ourselves, well, what does this benchmark fact equal? And since 4 times 3 is a benchmark for us, we know it. It's easy to solve. We know 4 times 3 is 12. The second 4 times 3 also equals 12. So we add 12 plus 12, which equals 24. That means that 4 times 3 plus 4 times 3 equals 24, which means our new fact, 8 times 3, equals 24. So just like with less area compare and more area compare, when students are attempting to apply the splitting strategy, a lot of times they don't know when to use it, and they have a hard time determining a benchmark fact to use with it. And so I think it's really helpful to intentionally teach students what factors the splitting strategy is really useful for. So for a lot of students, the splitting strategy, like we just looked at, is useful for solving 8's facts because you can always split an 8 into a 4 and a 4. You can split it into two 4s, and many students do know their 4's facts. So if a student is strong with their 4's facts, splitting an 8 into a 4 and a 4 is a really helpful strategy. So here you can see I have the fact 8 times 7. That's a pretty tough fact. And there aren't a lot of great benchmark facts aside from splitting that a student could use to solve this. So if a student didn't know 8 times 7, they could split the 8, pardon my number bond, into a 4 and a 4. And I like to have students show, certainly at least when they're still learning it, show the splitting of that factor using a number bond, so that they can really see what they've done. And then of course the factor we did not split, the 7, is going to become our common factor. And I like to have kids circle that just like they do in more area compare and less area compare. That 7 is our common factor, so when we're splitting, that 7 is going to show up in both of our benchmark facts. So here we have our 2 benchmark facts. We're going to have 4 times 7 plus another 4 times 7. So we have split that 8 by 7 into 2 smaller benchmark facts. 4 times 7, you'll have to forgive my writing, and 4 times 7. And of course we have to add those 2 benchmark facts together to equal 8 times 7, our new fact. Now if a student is choosing to split an 8 into a 4 and a 4, if they're choosing to split this 8 by 7 rectangle into 4 times 7 to 4 times 7, they should know the fact 4 times 7, which of course is 28. And then they'll add another 28 because we've split the 8 by 7 into 2 4 by 7s, and 28 plus 28 is 56. So that tells us our new fact, 8 times 7 equals 56. So like I said, splitting can be really helpful for 8's facts, and there really isn't another strategy that's great to use with a factor of 8. More area compare and less area compare both don't work, are not very helpful to students usually with factors of 8 because they don't know the facts that would have to be the benchmarks. So splitting is really a great tool for that. Another another factor I should say, forgive this, there we go. Another factor that the splitting strategy can be really useful for is a factor of 4. 4's facts, or facts that have a 4 in them, can be split because 4, of course, can be split into a 2 and a 2. And students are very strong generally with their 2's facts. So we'll go ahead and solve 4 times 7 right now using the splitting strategy. So if a student didn't know 4 times 7, they could go ahead and split or decompose their 4 into 2 2's. And then, of course, the 7 is going to be the common factor. We're not going to split the 7. So that becomes our common factor. And then this is going to create for us 2 benchmark facts. So we have 2 times 7, the first 2, times that common factor of 7, plus the other 2 times our common factor of 7. And that will equal 4 times 7, our new fact. Now, again, if a student's choosing to use the splitting strategy here, they should know 2 times 7 equals 14. It's not a good benchmark if they don't know it. So students are going to need to add 14 plus 14, which equals 28. So 4 times 7 equals 28. Splitting is obviously very different than more area compare or less area compare, but it is really useful, like I said, for 8's facts and also for 4's facts, and some students really take to it, maybe even more than they do to more area compare or less area compare. So all that to say, happy splitting!